Welcome to GoodTecher LeetCode tutorial. This time we are going to solve maximum depth of binary tree coding problem. So given a binary tree, find its maximum depth. So maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So note here, a leaf is a node with no children. So for example, given binary tree 3, 9, 20, now no nodes on the left side anymore, and 15, 7. So this binary tree, we see that the root node is 3 and the farthest leaf node is 15 or 7. So starting from the root node, so if go to the farthest leaf node, that's 1, 2, 3, 3 nodes. So 3 nodes, that means the maximum depth for this binary tree is 3. So return 3. So maximum depth of binary tree is a typical and popular coding problem about a binary tree. It's a simple, but it's very popular thing. So let's take a look at how to solve this maximum depth of binary tree coding problem. So for example, we have this example binary tree 3, 9, 20, 15, 7, as we just mentioned, from the root node to the farthest leaf node. That's a maximum depth. So like 1, 2, 3. So return maximum depth for this binary tree is 3. So it's easy from observation about get conclusion of this maximum depth of binary tree. But we need to find an algorithm to work well for any kinds of binary tree. So we need to list all kinds of scenarios. So first, we can list a very edge cases scenario. So in that case, this binary tree doesn't have any node. It's just null, empty tree. But based on the definition, there's a 0 node, so we simply return the maximum depth is 0. And second, so we can have a scenario that only contains one root node. The binary tree only contains one node, that's a root node. So in that case, we can also simply return a result that's just 1. So maximum depth is 1, just the root node itself. So third, so that's just like a normal scenario. So root node contains a left child and right child. Maybe on the right side have even more level. So in this case, we are actually looking for the farthest leaf node of this binary tree. So we can use a very popular methodology called the divide and conquer to solve this scenario. So we are going to look at the left side of the root node and right side of the root node to compare the depth of the left side and right side, and then get the maximum the bigger number of the left side or right side, and then add this depth to the root node. So what we are comparing to do is that we are compare left depth and the right depth. So we check whether the left side have a deeper level or on the right side have a deeper level, and get the bigger one, and get the bigger one plus the root just 1 level, we will get the maximum depth for this binary tree. Like for this example, the left depth is just 1 because 1 node, but for the right side there's like a 2 level, so we use right side. So right side is a 2 and plus is 1, the first level root level, we get the maximum depth for this binary tree is just 3. So this is a algorithm. So look at the left side and the right side, get the depth, compare, get the bigger one plus this 1 root level, and get the maximum depth for the binary tree. Okay, so we list all these scenarios, so we can go back to the coding to code and solve this coding problem. So as we just mentioned, so first scenario we could have is we can have a scenario that if root is null. If root is null, that means there's no nodes, we simply return 0. Otherwise, we are going to check the left diffs. So use a divide and conquer. So divide and conquer maximum diffs to get the left side diffs. And right diffs. So max diffs root not right. And what we are going to return here is just max maximum diffs. So that's a bigger number between the left diffs and right diffs. And plus 1. And we can return maximum diffs. So that's it. So if that's a root node is null, we simply return 0. Otherwise, we go to see the left side and the right side, get the both sides of maximum diffs and compare which one is bigger. And the bigger one plus 1, we get the maximum diffs for this whole binary tree. Okay, click submit. Okay, accepted. So we successfully solved this coding problem. So there's a correct answer for this coding problem. So like we see, even this is a simply very simple binary tree coding problem, but it's a very typically seen in many companies interview. So just practice to master all kinds of binary tree coding problem. So like whenever we facing a binary tree coding problem in a real coding interview, we're confident to solve those problems. Okay, thank you for watching. Thank you for subscription to GoodTecher LeetCode YouTube channel, and see you next time.